Hi, I'm Yassine, and I'm going to talk about my research work as part of the Greenedge initiative. Today, larger and larger amounts of data are being exchanged from self-driving cars, smart health systems, um, smart grids, and this comes with a risk of highly increasing the carbon footprint related to these transmissions. Hence, it is important to contain this growth. And that is where compression plays a vital role. And I am specifically working on compression in image and video communications who target human observers, human beings. So the problem is with previous compression algorithms is that if you compress an image too much, then it starts becoming blurry, or there start being uh, artifacts that are not visually pleasing. But what if we could compress an image further and further without having displeasing visual quality? A researcher from Google says that I have a dream that one day we can compress an image as much as we want without losing any visual quality. And indeed, recent algorithms have been surprisingly successful. And in particular, this is what I study theoretically, mathematically. I study perceptual quality in a mathematical sense. Um, and what inspires my work is the recent advances in compression algorithms where generative AI has been used. Indeed, in many applications, the human observer does not really care if we slightly modify the background of the image or video. Think about, for example, a building that is far in the background. There is no need to include that building in our compressed image. Indeed, we can just have some generative AI algorithm generate an image, a building in that background, which will be roughly of the same shape, um, without it being included in the compressed file. So we have a smaller file, and then when you open the file, you get a building that is generated by the algorithm. If the background is not important, then the human will probably not notice. So instead of having a blurry image, we will get a very nice looking image, in particular, a very nice looking building in the background, although it might differ slightly from the original image. And this has allowed to produce extremely beautiful images with very low file sizes. I studied this theoretically from an information theory point of view. And in particular, what I found really interesting is that when we look at this kind of compression and we take visual quality into account, it so happens that sometimes randomized compression algorithms are more successful, lead to smaller file sizes or better visual quality. Randomized algorithms being compression algorithms where there are random numbers used or pseudo-random numbers used. And this was all for this brief presentation. I really believe that we are seeing amazing progress in image compression and video compression, and that this is really important to contain the growth of data exchanges and the related carbon footprint. And I thank you very much for your attention.